Hello, hello, Stanley. How you doing? So this is section chapter 2, and this is somewhere around 2.4, and we're looking at simplifying polynomials and or rational expressions, which is one polynomial divided by another. And this is what was on your board. So I'd like to address that, and then I'm going to make a video about these specific homework assignments. But let's do this first. So a hint I gave you on your text, and sorry if the text is annoying, we can always figure out a way of just setting up emails. But here is that problem. So let's have a look at it. And then I'll do homework here on a different page, okay, on a different video. So the hint I gave you first is notice that this is divided. Notice that this is divided. And you really don't want to get into dividing fractions because they're really annoying. But I gave you a hint, and I said earlier that the fractions 3/5 divided by a fraction of, let's say, 4/9 is the exact same as taking the first fraction, 3/5, and multiplying it by the flip of this, 9/4. That will help you a lot, because once you have it multiplied, you will be able to cancel tops and bottoms with tops and bottoms on either side. It's very important to understand that, and if you don't understand it, take your calculator, take the decimal of this fraction, divide it by the decimal of this fraction, then take your calculator and take this fraction and multiply it by the decimal of this fraction. You will find it's the same result. Let's take this exact one and figure it out. So let's look at this first part. Boom. And what I'm telling you is it's the same as multiplying the flip of this one. So let's flip it. So I'm lucky in that my thing lets me just grab them and make new fractions. So I'm flipping it, and then I'm taking the top part and I'm putting it on the bottom now. Now, you might say, why? Why? Because dividing fractions is a pain in the butt, and it takes a long process, and it's always easier to multiply. Why is it easier to multiply? So now I've got a multiplication in the symbol. Because if you're multiplying, we're essentially now putting this in a bracket and this in a bracket, and we're putting it right beside each other. Putting it, I have to take the selection tool. We're putting it right beside each other as multipliers. And the same with the bottom. We're taking this bottom part and this right part, and we're putting them right beside themselves as multipliers, and essentially we're making one great big dividing bar between them. Well, why would we want to do that? Well, as you saw from simplifying, when you have stuff that's at the top that's similar, if this was the same as this, we could just cross them out. Or if this was just the same as this, we could just cross them out. And they're not right now, but you'll discover as we simplify them and factor them, we will find them out. Now, obviously, this one over here, is it a difference of 2 squares? No, it isn't. And usually I would say put my p square on the left side and start from there and go from there. But we're not going to do that. We're going to just keep it as is. But down below, is that a difference of 2 squares? Almost. If that was just 16, yeah, that would be a square root of 4, and that would be a square root of 2p, but it's not. We got a p in there, but maybe we're going to be able to simplify it up top somehow. Maybe not. Let's instead look at what can be factored out of the top. What do they have in common in the top? Well, we got 21 and 3. They both happen to be divisible by 3, so that's probably something we'll take out. And we'll also have a p and a p in common, and that we'll take out. So let's get to work on the top. We're going to take 3 out, and we're left in brackets. If ever you want to figure out what's left, it's essentially when you're taking something out, you're dividing both these numbers by that thing. Proof of that is when we expand in the reverse direction, we're multiplying, right? When we expand something, we multiply it out. Well, then factoring something outwards must be dividing. So we're going to take each of the terms in the middle, and we're going to divide by what we take out, and we're taking out 3p. So we'll look at 21p and we'll divide it by 3p. Well, 21p divided by 3p, there's no p's left. Those become 1. P divided by p becomes 1 over 1. And 21 divided by 3 becomes 7 over 1. So we got nothing left at the bottom except for 1 and 7p at the top. Or do we even have that at top? No, 21p, we got nothing, we just got 7. So we're just left with 7. And what about minus 3p squared divided by p, 3p? Well, minus 3 divided by 3 is minus 1. And p squared divided by p is simply p with 1 at the bottom. So we got nothing at the bottom. We're left with minus 1p at the top. So let's get rid of that. So we're left with minus p at the top. And that's all we're left with. So when we factor out 3p from the top, boom, that's what we got. Well, I got a news for you. Well, there's probably a hint that we're going to be factoring, coming up with 7 minus p in the bottom. And you might say, well, I'm used to having it p squared minus 9p plus 14. And you can do that, and that's fine. Or you can leave it in this shape, and you'll discover it still factors out the same way. And we'll look into that. Let's look at this bottom one here, and right away I can see, well, they both have 4 in common, and they both have p in common. So let's factor that out in the bottom. So again, we're trying to take 4p out of the first term here. And so we simply take each term and divide it by 4p to see what's left. So we got 16p divided by 4p. Well, 16 goes into 4 goes into 16 4 times. We're left with 4, 1 at the bottom. And p goes into p 1 times, which is left with 1, 1. So those are essentially nothing at the bottom. Up top, we're left with simply 4. So let's get rid of all my handwriting. And the first thing I have in the bracket is 4. And then plus, and what's 4p squared, which is this term, divided by 4p, what we're factoring out. Well, I think you quickly see those cancel out, and these cancel out except for p up top. So we're simply left with 4 plus p at the bottom. Well, that's not important. Well, hint, hint, it probably will be with these other terms. So that's a good hint to what we're going to be looking for at the other terms. I suspect we're going to be getting a 7 minus p as one of the factors down here. And I suspect we're going to get a 4 plus p as one of the factors down up there. And that always helps you along the way to look for those things. Well, we're looking for something these are simple factors because they're just p squared. And we're looking for something that is going to produce a product of 12, and add up to 7. Well, fortunately, 12 does not have many products. It's got 12 and 1 and 4 and 3 and 6 and 2. The only one that adds up to positive 7 is 4 and 3. So right away, I can see my factors are going to be 4 and 3. So that means the top factor, this term up here, this trinomial, will factor into 4 plus p and 3 plus p. And you might say, well, Peter, I'm used to it being p squared plus 7p plus 12. And if you want to, you can rearrange every term in here in that order. And you're going to have to rearrange them in that order to get it that way. And that's fine. But you'll notice like this 7 minus p would end up being minus p plus 7. So we'd have to factor out another minus 1 to get it into a p minus 7 routine. Why not just leave it the way it is and stretch our brain a bit and learn to factor backwards? Just to test yourself out, let's make sure it's right. Well, 4 times 3 is 12. That's good. And 4 times p is going to be a 4p, and p times 3 is going to be a 3p, so we'd have plus 7p added up. Well, that's right. So far, so good. And the last term links a plus p squared, and that's right. So this is indeed a correct factoring of this top one. And look, of course, there was the hint right away. So we're just going to have our factors like this. Now, what about the bottom one? Same thing. We're going to look old school method, and we're going to look at it. And what we're looking for is a number that multiplies up to 14 but adds up to minus 9. So we're going to look at the same thing over here. What number multiplies up to 14 and adds up to minus 9? Well, 14 doesn't have many multipliers either. It's 14 and 1 and 7 and 2. It's pretty easy to spot the 7, 2. The only way it'll work is if it's minus 7 and minus 2, that multiplies out to a positive 14 and adds up to a minus 9. So right away, we found out our multipliers are going to be minus 2 and minus 7. So we're going to use those as factors in the bottom. And it becomes factors out to 7 minus p and 2. Oh, wait a minute, Peter. You said it was going to be a minus. Yeah, well, the minus p here, I'm used to putting a minus here and factoring out. Well, let's try it out and put the minus with the p instead and see if that will create the factors we want. 7 times 2, that creates a positive 14. That's what we were looking for. But we need a minus 9. Well, trust that the minus p will do it. What's 7 times minus p? It's minus 7p. What's minus p times 2? Minus 2p. And that ends up adding up to minus 9p. And then what's minus p times minus p? Plus p squared. So we see that we get the terms that we wanted and the bottom by not rearranging it and just putting the minus with the p instead. That's a little stretch your brain moment. You're going to have to learn to factor backwards. That said, we can rearrange it. At the end of this video, I'm going to rearrange it, and we're going to learn how to factor it the other direction too. Just takes a little bit longer, but maybe that's your comfort zone. Notice, though, that my hint was right. Up here, I said, watch out for 7 minus p down there. Sure enough, we got it. Just a little, you're just going to have to stretch your brain a bit to realize that while we came up with minus 2 and minus 7 as the factors, making the minus p helped create those minuses as well. You'll get used to it. Like I said, I'll rearrange it at the end so that we go in the way you're used to. Now, before we look at simplifying, we must find our exceptions. Let's look at this one. If p is 0 here, it makes the whole thing 0 and multiplies everything out to 0. So we know that p cannot be 0. And then now you might say, well, I'm used to doing it like p plus 4 the other way, but it still works. What would p have to be for 4 plus p to be 0? P would have to be minus 4, because 4 plus minus 4 is 0. If you want to do it equation-wise, we move the 4 to the other side. P, b, minus 4 would make this equation 0. So we know that p cannot be minus 4. Still logical, still works in our head. So again, p cannot be 0, and now we see that p cannot be minus 4. If it were, this whole parentheses would be 0. Let's go on. What about the next one? Well, it's pretty easy to see that if p was a 7 here, it would make 7 minus 7 0. So we know that p cannot be 7. So we found another exception. P cannot be a 7, like that. And what's the exception here? Well, if p was 2, 2 minus 2 would be 0. So we know that p can also not be 2. So we know now that p cannot be 7, p cannot be 2, p cannot be minus 4, p cannot be 0. Now that we have our exceptions, we put them aside and we start simplifying. Let's look for common things at the top and bottom. Right here, I have a 7 minus p and a 7 minus p. Just one of them, so I can just turn them into 1 or simply get rid of them. Again, here's a 4 plus p and a 4 plus p, sort of what I was thinking was going to happen at the bottom, and we can get rid of them. So we might be done, but look at this. These 4 and 3 can't be nullified, but we got a p and a p. They divide each other out to 1, so we simply get rid of them. And we're left with 3 plus p at the bottom, and 4, 2 minus p at the bottom, 3 plus 3p at the top. Rewriting it nice and neat, and I know I'm not very nice and neat, is simply like this. 3 plus p, 4 divided by 4, 2 minus p. And that would be the final answer, and that's legit. And you're allowed to rearrange these. So this one rearranges easily. 3p plus 3, if you want to see it logically. Down at the bottom, it becomes divided by 4 minus p plus 2. We don't necessarily like that. If you wanted to rearrange it in this way, we could. We don't have to. We can just leave it like this. But if you wanted to, you would get that minus out of there. So you would factor out, divide everything by minus 1 in here. That would put the minus in front of the 4, and you'd be left with p minus 2 in the bracket. That's if you wanted to arrange it so p's first. There's no need. This is totally fine as an answer because we started in that format. and it still works out no matter which way we arrange the p's and take minuses out to balance it out. It doesn't matter. It's still legit. So this is a correct answer, and this is a correct answer on the left here. 3 plus p, and then minus 4 down here, p minus 2. That's also a legit answer, and you could also simply move this minus up to the top or in the middle, wherever you want it, and that's a legit answer. It's saying, well, the minus is either here or here. We like putting it at the top. Both of these answers are correct. We've simply rearranged the minuses on this one, and your teacher would still accept this answer. If he didn't, he's a bit of a jerk because he started the question that way. End the video if you understand it, but I'm also going to do a version where we take the same question and we rearrange it the way we're comfortable, if you want to do it that way, because you're not comfortable with the way the teacher phrased it. So all we're going to do is we're going to end up reorganizing all the terms the way we like it. So let's look at this first term. First of all, we're going to flip our fractions the same way. So this divided by that is the same as this multiplying the flip of the second one. So I'm going to put this up top and this at the bottom, and the reason we multiply is so that we can put all the terms beside each other. But before we do that, let's look at, so this is our new equation, let's look at putting the terms in the way we like it. We like the p squared first here. So we'd have minus, and you'll see why we don't do it, because it just creates a bunch of negatives we don't want. It ends up being minus 3p squared plus 21p. Well, we don't like the 3 in there. Fortunately, when we factor things out, we can take the minus 3p instead of plus 3p. And we end up with minus 3p factored out. And in the brackets, we're left with p minus 7. Instead of what we had before, which was 7 minus p, right? So you can see that things are still going to work out taking these minuses out. And why we know that is because at the end you're going to discover there's just one minus at the top, just like I had in my second version. So that's the factor of this first one rearranged. What about the second one rearranged? Well, the second one here, I'm saying that you might like it or are more comfortable putting the p squared first, 4p squared plus 16p. And we'll see that that rearranges fine, no problem, because of this plus. There was no need to rearrange the minuses. So we're still going to factor out 4p in the bottom. And we're going to be left with, just as in the other thing, 4p comes out. You're left with 4. Oh, sorry, we've rearranged it. We're left with p plus 4. Just like the previous one, but the previous one we were left with 4 plus p. Same thing. It's still working out. And notice all of a sudden, and that's not a minus, that's just the division. Notice now we have that minus that I came up with when I rearranged it in the p format. So now we can see where that minus came from. Now, what about the second term rearranged? Well, everything in the second term here is plus, 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 so the rearrangement of it is fine. And we end up with just p squared plus 7p plus 12, which, as we already showed, factors out to 3p plus 3 and p plus 4. So let's just do the factored version right away. P plus 3, p plus 4. You're also going to discover your exclusions on the bottom are exactly the same, whether there's a minus in front of them or not. Okay, and what about the rearrange of the other one? Well, this is a little tricky because the minus is in the middle, but thankfully the p is positive, so we won't have to take out any negatives, and we just rearrange it like minus 9p plus 14. The factors are still going to be the same. Minus 3, minus 4, but this time the minus is going to be with the p, the middle term, instead of with the beginning, so that factors out to p minus 3 and p minus 4. And you might have said, well, before it was, I'm going to get rid of the square, before it was 4 minus p, and p minus 3. And now look, we don't have those factors the same anymore. We don't have these factors the same anymore. Yeah, that's the issue. Is you might say, oh, these can't be factored out. And, well, actually, they were never factored out to begin with, I don't think. I think our final answer, I'll have to go back and look. Because it still ended up 3 minus p at the top and 3 plus p at the bottom, and there's no way those can factor out, so that doesn't matter. We've just rearranged it the way we like. We're still going to end up with the same cancellations. You still have to find out the exclusions, and guess what? Your exclusions are still the same. It didn't affect the exclusions. P still can't be 4. It's 4p minus 7. Is that, did I get it right? No, I got it wrong at the bottom. That's why I'm getting all confused at the bottom. It's not 4 and 3 in the bottom. It is 7 and 2. Confusing, confusing, confusing. And that's why I shouldn't drink in the afternoon. So, there we go. Now, looking at our rules, still P cannot be equal to 4. P can still not be equal to 0. P can still not be equal to 2. They're just easier to see the rules this way. P cannot be equal to 7. Those are still the same exclusions. So it didn't change the exclusions at all. Now we're going to look at what can be canceled out in red. P minus 7 here. P minus 7 here can be canceled out with that. P plus, not P plus 3, P plus 4 can be canceled out with that. This P can be canceled out with that. And we're left with, as a final answer, minus 3, P plus 4, P plus 3 rather, divided by positive 4, P minus 2. This ended up being the same answer, except to rearrange this P to get it from 2 minus P, I had to take the minus out, which ended up top before, to get it reordered. That's all that happened, is that the reordering of these, having the P first as a positive, meant I had to create a minus here. It is actually the same answer. If, for instance, I were to rejig this backwards, where the number is the way we figured it out in the middle, I simply rearrange what's in the bracket. So I get minus 3, 3 plus P, so the top works fine. But at the bottom, to get it rearranged, it becomes minus 2 plus P. Well, I didn't want that minus 2 before, so I ended up taking a minus out, and I ended up with 2 minus P. And look at that, these minuses cancel out. So look at that, I ended up with the same answer. These are actually equivalent. They are the exact same fraction. Whenever you just simply rearrange minuses like that, you're keeping it all balanced. That's why the minuses can go into the bracket or come out of the bracket, and it ends up being the exact same fraction. So both answers are legit. Whichever way you're more comfortable, you're allowed to rearrange the brackets because they are simply added or subtracted inside of themselves. It doesn't matter how you rearrange numbers. That's a rule of math. It doesn't matter how you rearrange numbers in a bracket. If they're all being added and subtracted, A plus B minus C is the same as minus C plus A plus B. It doesn't matter how you rearrange them. This answer will be the same as that answer. That's a rule of math. So long as you keep the symbols the same. You can't suddenly make this minus A if this was plus A over here. You're also allowed to change all the symbols in the bracket, for instance, by taking a minus 1 out, and that will change all the symbols in the bracket. So if I factor out a minus 1, all the symbols change, and I get C, so that changed. Positive C, minus A, so that changed. Minus B, you're allowed to do that. I've changed all the symbols in the bracket by factoring out a minus 1. Makes sense. We're essentially saying, I want to flip all my symbols. Later on, when I want to flip them back, I have to remember to multiply the minus 1 into them to bring it back to this. That's all that's happening. So as long as you follow the rules of math, the rules of math are, whatever I do to the right side, if I add a 3 on the right side, I must add a 3 on the left side. If I am getting rid of a fraction on the right side, let's say 3 over 4, and I want to get rid of the 4, 3x over 4, and if I multiply by 4 over 1, which is the opposite of this fraction, then I must remember to multiply 4 over 1 on the other side. So that's 4 in the numerator. That's why I say, oh look, the 4 just goes up top, because these cancel out. If you wanted to get rid of all of this fraction here, guess what you would do? You would multiply by its opposite, 4 over 3. And that's because by multiplying it, these cancel out, but you have to remember, whatever I did to the right side, I have to do the left side. Whatever I do to the left side, I have to do the right side. It is also why, when you're adding fractions, when I'm adding 1/3 plus 2/4 plus 3/5, and I need to figure out what their common fraction is, I can say, okay, well, they all will become 60, that's for sure. But they also will all reach, they won't reach 30. These two will. Is 60 the lowest? I'm sure it's not. I'm just not seeing it right now. 6 times 5, yeah, 6 times 6. You're limited by this one. Let's just say it's 60. It's 20, it's not 20. Not 21, it's got to be either 15, it's not, 20, it's not, 25, it's not, 30, it's not, 35, it's not, 40, it's not, 45, it's not, no, 50, it's not. So it's, yeah, we're stuck with 60. That is why when you're adding up fractions to create the common denominator by 60, you're adding up the other two. So to change this to 60, obviously I have to multiply it by 20 at the bottom, but I'm not allowed to do that. I have to multiply by 20 at the top as well. Why am I allowed to do that? Because 20 over 20 is 1. When you're multiplying something by 1, you're not changing at all. We're just converting it to a new fraction. So 20 times here on the top is 20, and 20 times 3 on the bottom is 60, which was my goal, to create the denominator 60. How did I figure out to multiply by 20? Well, what are these two multiplied together? 20. That's the only thing I'm missing over there. I already have the 3. So I'm simply multiplying by 20. You can do the same for the other fractions. So this is my new fraction here. What do I multiply this fraction by to create 60? Well, what's 5 times 3? 15. I'm allowed to multiply this fraction by 15 over 15. So what's 15 at the top? I end up with plus. 15 at the top is 30. And what at the bottom? 60, of course. So I multiplied it by 1. I didn't really change it. I just found what the fraction is over 60. Finally, this last 5, what would I multiply it by? Well, what's 4 times 3? It's times 12. So whatever I multiply the top by, bottom by, I must multiply the top by. So I end up with 36 up top. These now all have the same common denominator. You are now allowed to add or subtract them. So I'd end up with 36 plus 30, which is 66, plus 20, which is 86, which is 86 over 60. You're now allowed to simplify that fraction because 86 is higher than 60. How many times does 86 go into 60? Well, I can only put 1 in. So this fraction is now equal to 1. If I take 60 out of this, what am I left with? 26 over 60. Is that the simplest form of that? No, let's divide it by 2 and see if this fraction by 2 and see if I get a better number. I'm left with 1, 13 over 30. That's the smallest possible fraction. How do I know? Because 13 is a prime number. So boom, that is the answer of what is 1 over 3 plus 1 over 4 plus 1 over 5. The answer is it's 1 and 13 over 30. Ugh. Rules of math. That's all you got to follow. The rules of math. If I have a square on this side and I want to get it just to an x, the only way to get rid of a square is to square root it. But whatever I do, and that brings it back down to just x. But if I square root the right side, I must square root the left side. There's an interesting rule to that, is that when I create that square root on the left side, I must now introduce a plus minus sign. That is because 3 squared, which is possible here, makes a 9, but minus 3 squared also makes a 9. So I must remember that if I'm square rooting something all of a sudden, I'm creating the possibility of a plus or minus number. So you must always add the plus minus in front of a square root that you create. And that's to account for possible negative numbers that lead to the same value of x. 9. Okay, what about if I have a square root on the left side? How would I get rid of it? It's the same thing. If I'm trying to get x all alone and I can't get rid of it, I must square it. I must square it, which means whatever's on the right side, I put in brackets and I must square all of it. Now, why don't I put a plus minus there? Because when you square something, it doesn't matter. You're not creating a potential plus minus situation. You're simply squaring whatever exists, and whatever exists is fine. So you don't have to do a plus minus for that. It's only when you do the square root. Let's look at ways of getting rid of fractions. So obviously if I had this, let's do it with y. And I said to you, well, I want an equation that says y equals. So I want y all alone on the left. You'd say, okay, well, these are married. It's 3 times y. So 3 times y, I must divide a 3 to get rid of it, which means I must divide a 3 on this side. So I'm left with just y is equal to x over 3. That's easy to see. What if I now have 3y plus 3, plus 4, let's say, is equal to x? Well, you might say, well, I'm just going to divide by 3. Well, you can't, because this straggler got added onto the fraction. If I'm dividing this by 3, I must divide this by 3. And that's allowed, actually. And now you can now divide this by 3. But it didn't solve your problem. You now have a y plus 3/4 here, which actually still works. You can do it like that. You just must make sure you divide the 4 by 3 as well. But why do that? That's messy. This is a straggler all on its own. Let's get rid of it instead by subtracting it. It's being added as 4. We must subtract it as 4 to create 0 there. So 3y plus 0, that's the same as 3y. But I subtracted 4 to the left side. I must subtract 4 from the right side. Now I can divide my 3. They cancel out. And this is all divided by 3. Why did I say before it was okay to have the 3/4? Well, look. Look, that's 3/4. This could also be rewritten as x over 4 minus 3 over 4. And that's what would have happened if I divided before subtracting the 3. So it still works, because then I have to bring the minus 3/4 to this side. It just makes it a little harder. In a way, this is good if you're trying to come up with a line formula, because this is the same as, so I'm going to just get rid of it. This is the same as the line formula, y is equal to 1/4 x, so I've simply taken the quarter right out of this, minus 3/4. So this line crosses the y, has a y-intercept of 0, minus 3/4. And then its slope is 1 over 1/4, which means its rise is 1, and then its run is 4. So to figure out the next coordinate, I just add 1 to the y and 4 to the slope. So the next point on this graph will be 4, 1 minus, minus 3/4 plus 1 becomes 1/4, positive 1/4. So that's the next line on the slope. So that's why you do it, is to figure out formulas that are manageable to graph. That's really why we're doing most of this, or formulas that are manageable to understand. That was a damn long video for a very simple thing. You were allowed to quit at any time in these videos, whenever you get what I'm saying.